math students, let us do the 2016 board paper. So we've already done the 2017 board paper and please be careful. As I said, chemical kinetics chapter, it includes, or you'll be given the numericals only based on your theory which you have studied. So let us come back and solve the 2016 paper. Yes, let us read the question. For the first order thermal decomposition, okay, so this is the first order rate equation given to us. The following data were obtained, right? As soon as I see this reaction, I can clearly say there is only one reactant participating in the RDS, that is rate determining step. So it is a first order rate equation. Done. What should I find out? I have to find out rate constant K. Okay, and some data is given to us. So what are you observing here in this reaction? All are gaseous products, right? Yes. So when they are gaseous product, obviously it is understood they exert certain pressure, isn't it? So that pressure is given in this particular context, that is they exert certain partial pressure on the surface, isn't it? So that pressure is given to us in the term measured in atmospheres. Okay, so what am I trying to explain? Let us see. As soon as such question is given to you, first they said it is your first order thermal decomposition. So you have to find out, first write the formula. So what is the formula you require? K is equal to 2.303 by T log, right? So basically what did we study in first order rate kinetics? It was A by A minus X, isn't it? Normally, but here what are we going to study? Instead of this, we are going to write a formula called individual or partial pressures by partial pressure minus X. Okay, this is the formula for such gaseous reactants. I'll explain what it is. Now, as soon as you write the reaction, now start your answer. Now pick up that C2H5Cl, your gaseous state, your in the presence of H nu, sunlight, is going to give you C2H4 this plus HCl gas. Right, done. Now what happened? Initially, when the time was 0 seconds, the pressure exerted by this particular one, when it was initially, the pressure exerted by this was how much? 0.30 atmospheres. Okay, so what do I write? I write Pi is equal to the individual pressure, the partial pressure exerted by this is 0.30 atmospheres. Right, now what is the time here? T is equal to 0 seconds. Yes, now observe. Will there be any pressure exerted by this? No, because they have not yet decomposed, isn't it? It has not yet decomposed at T is equal to 0. Done. Now gradually come back. Now at T is equal to 300. Yes. Now what will happen to this partial pressure? This goes on decreasing, and the certain amount of pressure exerted by this particular gaseous product and this also, isn't it? Now at 300 it just started proceeding forward direction. So now the pressure exerted by this, I'm picking up it as X. This also I'm picking up it as X. Yes. Now this is X and this also is X. Now what will happen to the initial reactant concentration, or partial pressure, it becomes Pi minus X, isn't it? Yes, right. This is 1. This is also 1. It's also 1. Now, let me solve the whole thing. Now, for what should I do? I know what is Pi. What is Pi for this? 0.3. I have to find out this quantity. So I'm solving the whole thing to find this X quantity. What you take? P total. Now the total pressure exerted is equal to Pi minus X plus X plus X. Correct? Is equal to P total, right? Now just see, plus X and minus X gets cancelled. What are we left with? We are left with P total is equal to Pi plus X. Yes. Now what is P total given to us? P total given to us is 0.50. 0.50. Right. What is Pi given to us? Initial Pi is given to us as 0.30 plus X. Now X is equal to when this goes the other side, 0.2. Correct? Yes. Now I have got X value. Now what should I find out? Once I've got X value, I can substitute this X value. Now let me label this as step 1. Now let me come back to step 2. In step 2, I've got X value. So can I find out this X value here? So what is now since X is equal to 0.2, now substitute this value in this Pi minus X, right? This is what I have to show. So what is Pi now? We have got Pi as 0.3. 0.3 minus 0.2 is equal to 0.1. Now I've got everything, isn't it? Yes, all the data is with me. I have solved it. I've got 0.2. I've taken the same value, substituted in this, and I got 0.1 ATM. That is over now. Okay, ATM. Now substitute in this data. So what I'm going to do, I'm going to erase this part now and observe carefully. So I'm going to solve this whole thing using this. I'm going to apply this. So what is this? What should I find? K. K is equal to 2.303 by T. How much is T? I've given in the this one. T, I think I've got 300, correct? Into log. What is Pi, which I initially have? Pi have is 0.3 divided by what is Pi minus X? We've got 0.1. Correct. So what will this become? K is equal to 2.303 by 300 the log 3. Already this log 3 value is given to you. How much is given to you? Log 3. Substitute that value of log 3. That is 0.4771 is given to you. So let us write K is equal to 2.303 by 300. Your log 3 is 0.4771. Once you solve this, you get an answer of 0.0037 second inverse. That is your unit for your first order rate equation. So once again, let us see. First, as soon as such question is given to you, if it is given as first order, try to write that formula. And here what happened, they've given us gaseous reactants. So instead of A by A minus X, I have written the partial pressure reactants. I have taken that. So initially, this is your basic reaction, isn't it? So what did I assume? At 300, T is equal to 0, initial partial pressure exerted is 300. Sorry, 0.3 atmosphere, which is given. But as the time proceeds, this also increases. This also starts inserting or showing partial pressure. This also starts showing partial pressure. So that whole thing I've subtracted because Pi is the total Pi minus X. After that, I try to find out from this formula Pt is equal to total of everything. So Pi minus X plus X plus X. Cancelled it. Then I'm left with Pt is equal to Pi plus X. Done. Now PT, what is PT given in the table? PT given in the table is 0.5. Pi given is your 0.3 and plus X. I got X value. I took that X value and I substituted in this formula. I got 0.1. I took the same thing and I substituted in the formula. Log 3 is already given. So I've got an answer of this.